Okay, let's take a look at another example of induction, proof by induction. This one we want to show that 1 plus 2 plus 2 squared plus 2 to the third plus all the way up to 2 to the n minus 1 is going to equal to 2 to the n power minus 1. Now, what we're looking at here is if I were to plug in different values for the n here, for example, if I plugged in n is equal to 1, 1 minus 1 is 0, 2 to the 0 is 1. If I plugged in n is equal to 2, 2 minus 1 is 1, 2 to the first is 2. If I plug in n is equal to 3, 3 minus 1 is 2, 2 to the third, 3 minus 1 is 2, 2 squared is the 2 squared here, and you see the pattern. So n is equal to 4, this is 1 less. So this is going all the way up to this value right here. Now first off, we show that it's true for n is equal to 1. Well, I said when n is equal to 1, this side is equal to 1. Now we're going to plug in the 1 for the n here. So we're going to have 2 to the first power minus 1. And this is a question mark. We're wondering if that's true. 2 to the first is 2, minus 1 is 1. So that checks. So this shows that it's true for n is equal to 1. Now second, we assume it's true for n is equal to k. So I'm going to come up here, and I got 1 plus 2 plus 2 squared plus 2 to the third plus all the way up to 2 to the k minus 1. We're assuming that's equal to 2 to the k power, then minus 1 down here. Okay, so we're assuming that's true. Then we want to show it is true for n is equal to k plus 1. So I'm going to come up here, and I'm going to have 1 plus 2 plus 2 squared plus 2 to the third plus 1, 2, 3. And if I plug k in here, I'm going to have 2 to the k minus 1 plus, and if I were to plug in k plus 1 up here, k plus 1 minus 1. So k plus 1 minus 1. Now keep in mind what I'm doing. I said n is equal to k plus 1, so I'm plugging in the k plus 1 for the n right here. And we're trying to show that that's true if I plug in the k plus 1 for the n over here. So I'm going to have 2 to the k plus 1 minus 1 to the side. Okay. First off, we're going to focus on one side and try to get it to look like the other side. So come over here. 1 plus 2 squared plus 2 to the third all the way up to 2 to the k minus 1 matches this right here, which means I can replace this right here with 2 to the k minus 1. So 2 to the k minus 1 and plus 2, and 1 minus 1 cancels, so we got 2 to the k. And we're wondering if we can get that to look like this other side. Well, think of it this way. If you had x plus x, like terms, since these are the same, you add the numbers in front of them. There's an invisible 1 in front of each one of these. That'd give us 2x. Now, we got 2 to the k, we got 2 to the k. They're exactly the same. So, we'd add the numbers in front of them. And if I were to put numbers in front of them, this would be 1 times 2 to the k minus 1 plus 1 times 2 to the k. And again, we're trying to show that that's equal to this right side. Using the same principle as combining like terms, where you add numbers that are in front of them, 1x plus 1x is 2x. 1, 2 to the k plus 1, 2 to the k is 2 times 2 to the k. And we're wondering if that's equal to this other side. Kind of tricky, but you have to keep in mind the like terms, how that worked. Now 2 is 2 to the first power. So we have this. We're wondering if that's equal to the other side. Now when you have 2 to the power times 2 to the power, you add the exponents. So 1 plus k is 1 plus k, or k plus 1, minus 1. And you notice at this point, it's equal to the other side. Now we showed it's true for n is equal to 1, we assumed it's true for n is equal to k, and we showed it's true for n is equal to k plus 1. And by proof of induction then, it's true for all values. And that's our example.